Okay, for number 10, there's a coin problem. It's possible we can't use the table to get our equations directly, but we can surely use it to organize our data, right? So we have the number of coins times the value of the coin equals the amount of money it's worth. In this case, we have dimes and we have quarters, right? Quarters. And the dimes are Louis, and the quarters are Julia. So a dime is worth 0.1 and a quarter is worth 0.25. We have an unknown number of dimes and an unknown number of quarters. However, we don't know how many total we have, but we know that the number of dimes equals the number of quarters. So there's our first equation. Then we multiply across and we get 0.1d. We multiply across, we get 0.25q. And now the problem says that Julia has $1.80 more than Luis. So Julia, this is the amount of money Julia has, right? So that amount of money, 0.25q, is $1.80 more than Luis. And Luis's money is this one, the 0.1d. So it's $1.80 more than 0.1d. So there's our system of equations. So I'm going to use substitution. I'm going to take the d and substitute it in for the q, right? So let's see what we get. We get 0.25q, which is d, equals 1.80 plus 0.1d. Subtract 0.1d from both sides, so we get 0.15d equals 1.80. Divide both sides by 0.15, right? 0.15. So 0.15 times 10 is 150, and then we need 30 more, so 12. So D comes out to be 12. So 12 dimes. And then since they said the number of coins were the same, it's 12 quarters, right? So 12 of each coin.